everybody, and welcome to the webinar. First of all, thank you for taking the time to join us today. My name is Ronan Cremin, and I'm joined by my colleague, John Leonard. So we're here today to talk about some upcoming changes in the web landscape, brought about by the introduction of user agent client hints that we feel will have quite a wide-ranging impact on some of you on this webinar today. So we're hoping to provide you with some information that will help guide you through this change and be useful to you. So before we begin, I would like to spend just a couple of minutes describing who we are, because this will help put the information in context and see where it's all coming from. Just one note of procedure. There should be a questions panel on the right-hand side of your GoToMeeting client. We will be taking questions at the end, so if you want, you can pop the questions in there and we'll get to them at the end. So over on the right-hand side, probably near the bottom of the panel. So a little bit about us first. We are from a company called DeviceAtlas. We're mobile and web specialists. We've been doing this for over 10 years. We have a market-leading portfolio of products, beginning with DeviceAtlas. This is a device identification platform for the web and app ecosystems. We also have a product called Device Assure, which is a device authenticity verification solution. And this lets you know if the device that you're in contact with is what it's claiming to be. And finally, we have a product called Device Map, made available in conjunction with the GSMA, which is a device intelligence platform for the mobile operator ecosystem. And again, that's offered in partnership with the GSMA. We're headquartered in Dublin, Ireland. That's where we're coming to you from today. But we have offices all around the world and customers in over 60 countries. And just to give you a quick snapshot of some of our customers, we serve 6 of the top 6 mobile operators in the United States. Over 20% of the Fortune 100 are direct customers, and many more are indirect customers. And this leads to trillions of requests per month, at least, handled by DeviceAtlas across a few different use cases, such as analytics, optimization, and targeting. And these customers are in media, we support Netflix and CBS; in analytics, Adobe, Nielsen, SAS; in ad tech, Verizon Media, Xandr, and the Trade Desk; and in retail, Amazon, PayPal, and Walmart. So these are very much global brand leading customers, and through these customers, we have a fairly broad view of what's going on in the industry, and this is what informs our opinion. But we're not just suppliers to the industry. We like to consider ourselves as playing an active role. So we spend quite a bit of time in industry associations and standards bodies. As I mentioned, we work with the GSMA. We work with the IAB on the Internet Advertising Standards. We work with the ITU, that's the standard setting agency of the United Nations that sets standards in the mobile and technology space. And we've done a lot of work with the World Wide Web's consortium over the years in authoring standards. We've partnered with a number of technology companies. You can see them on the left there. And over the years, we picked up quite a few awards for innovation and technology. So that's a quick summary of who we are. So getting on to the topic at hand, we're here today really to talk about user agent client hints. And before we can really understand what this is all about, you have to look at the standard that underpins this new proposal. So back in 2013, Google made a proposal in addition to the web standards called HTTP client hints. So this is the underlying standard behind user agent client hints. This standard was proposed in the Internet Engineering Task Force, and thus is tracked in the request for comment process. You can see it there on the right. So this has been iterated ever since, and is, it's an established standard these days. And the purpose of HTTP client hints was to, as it says on the slide there, to define and accept client hint response header that servers can use to advertise their use of proactive content negotiation. Now that's a bit of a mouthful. What that really means in English is that it allows a web server to request hints from a web browser in order to serve it better. So examples of these are things like there's a save data client hint, and that lets a web browser tell a web server or website that it's on a limited data connection or a metered data plan, and that an efficient representation of the page would be welcome. And so a lighter version of the same thing. The ECT, the equivalent connection type client hint, is a way for a browser to tell a web server how well it is connected to the internet right now, and again, for similar purposes. But there are quite a few more kind of pedestrian client hints as well, things like viewport width, screen width, device pixel ratio, and all of these they're hints, they're supplemental information that the web server can use if the web browser chooses to send them. So this is an additive spec, and clearly a good idea. It doesn't get in the way of anything. If you don't want to use them, you don't have to. So this underlying standard is currently supported in all Chromium-based browsers. So that means Chrome itself, Microsoft Edge, Samsung Internet, and Opera, but notably not Firefox nor Safari. So again, that's the underlying standard that underpins the user agent client hints proposal. So let's move on to that. So user agent clients hints is it's a proposal that sits on top of HTTP client hints and builds on it. Unlike the underlying standards, this one is managed in the Web Platform Incubator Community Group, so our WICG. And this is a W3C group that's set up to be a kind of a lightweight, quick way to discuss new web platform features. And the stated aim of this proposal is to reduce the passive fingerprinting area exposed to the network by the traditional user agent string. So eyebrows were raised a little bit at this proposal for two main reasons, at the stated aim for two main reasons. Number one, in a HTTPS world, which is our current world, the only entities that get to see the user agent string are entities that you've chosen to connect to. So nobody else gets to see them. Your ISP doesn't see them. No, your mobile operator doesn't see them. So no intermediate entities get to see the user agent string, only people that you've chosen to communicate with. The other reason for some pause at the stated aim is that I've lost my train of thought. Oh yes, if fingerprinting is something that you need to do, and there are much more powerful ways to do this, such as canvas fingerprinting or audio fingerprinting. So there are really powerful ways to do fingerprinting that don't utilize the user agent string at all. So how does the proposal achieve this aim? The method by which it does this is by removing some of the more granular information from the user agent string. So specifically, only the browser name, the major version, and the platform name remain in the user agent string with this proposal. All other information must be explicitly requested via a header that the web server must send to the client. So that's the crux of this proposal. It demands that the web server asks nicely for the information that was there previously. The status of this proposal, it's managed in this Web Incubator Community Group, but actually it's already live in Chrome. So the proposal has gone directly from incubation, in fact, to deployment, which is a little bit of a little bit speedy and not the normal way things are done. Normally, there's a whole standards track process that's supposed to kick in at this, but in any case, this is live in Chrome today behind a flag. So what does this actually concretely mean to people in the web landscape? DeviceAtlas has a tool to help you examine how your browser is behaving or your mobile device to see which headers it actually sends today on the first and second request. But rather than show you live, I'm going to call out the details on a slide instead. So if you're using an Android device today, the user agent string that it sends is something like this. So you can see there, it says it's Android 10. There's a model string, which is the VOG-L09. That's a Huawei P30. And towards the end of the string, you can see the Chrome major version, minor version, build version, and patch version. So there's quite a lot of information there. With the client hints, the user agent client hints proposal, this will change to the following. So I've highlighted the major changes in red. So beginning with Android 10, that looks the same as Android 10 in the initial version at the top, but that is just because my device happened to be on Android 10. The Android 10 with this new proposal will be fixed. It will always be Android 10 regardless of what your Android real version is. Secondly, the model has changed to simply just K. And again, that will be frozen. Every model will be simply K. And finally, the Chrome granular version numbers have been zeroed out. Only the major version, in this case 93, has remained. So some of this information has just moved to a new place. So there will be new headers in which this following information is made available. The mobile version is now announced in a Boolean header, hence the (1), which means true. The brand name and version of the browser in question are in the ch-ua header, so they're there. And the underlying platform, in this case Android, is in a platform header. So much of this information has moved to a new place. But the really good stuff has now moved to a header that's only available on request. So the items I've highlighted in red have moved to a new place in a new set of headers that you must ask for and only get them on the next request. So the model is there in model header. The full version of the browser in question is there in a full version header, and the underlying platform version or operating system version is there also. So the information is all there, but only on a second request. So what are the implications of this? Let's have a look at some details. The first thing is, as mentioned, what we call the first request issue. Many of the critical data points that you need to do your job in the web landscape are not available on the first request. So this kind of necessitates a reload or redirect of the client after you've asked it nicely in order to get the details that you may need to serve your page or to run your analytics. Now it is worth noting that the subsequent to the first request, if a server asks for the hints and the client chooses to send them, they will be sent thereafter in every subsequent request until the browser restarts. Now Google know that the first request issue is really an issue, so they have a partial mitigation in place in the form of a new proposal called critical client hints that in effect automates the browser retry if it chooses to send the additional details that it was asked for. This is supported by Chrome, but not supported by Edge. So it's a partial mitigation for the first request issue, but notably does not get around the delay factor, the performance hit. Another issue that must be considered with this proposal is cross-origin requests and iframes. Every meaningful web page these days has resources that are sourced from a different origin, and potentially also iframes in which panels of content are hosted. With this proposal, the host web page must explicitly grant permission to the iframes and the cross-origin sources if they wish to see the detailed model and device information that I just talked about. So in the case of a cross-origin request, you must send this permissions policy header. In the case of an iframe, in the HTML for the iframe, you must explicitly designate which hints this iframe is allowed to get. So it's quite a lot of, this is quite messy. Another aspect to the proposal is it opens the door to model collisions. In DeviceAtlas, we have, I think, 16 devices with the model name M1. And because the proposal simply sends a model header rather than a manufacturer and model header, you cannot distinguish between models that share the same model name. And finally, clients can simply choose to withhold the information. The This proposal, in effect, creates a new configuration point that browsers will probably let users configure. So there may be clients that choose to withhold the information, even if they support the standard, or the proposal, I should say, not the standard. So this all leads to quite a bit of complexity and uncertainty. At a macro level, the problem now is that you have two methods to support for the foreseeable future. If you're in the web community, there are now two ways to do things that was only one before. So concretely, the Chrome and Edge will support the new proposal, which isn't stable yet, by the way, but other browsers will probably not and will continue to support the old standard. And there will be billions of devices. I mean, there are billions of devices out there which will never be updated and will continue to support the previous standard. There's a saying in the tech community that the nice thing about standards is that there are so many to choose from, and this probably is an example of that. Another aspect to all of this is that debugging becomes much more difficult. So if you're a web analytics provider or an advertising network, if you're missing data about a device from a request, there are at least four new issues that could have caused that. It could be because it's the first request from that browser. It could be because you're in an iframe or cross-origin that hasn't been granted permission. It could be that the browser doesn't support the critical client int proposal. And it could be that the browser is simply not choosing to send the data that you asked for. And it's really difficult to debug this stuff in a rich web environment. So now let's have a look at the status and timing of all of this. Do you really need to care about this? So first of all, who's supporting this and who isn't? The major browsers supporting this proposal currently are Google Chrome, of course, because it's a Google proposal, Microsoft Edge, because it's based on Chromium, and Vivaldi for the same reason. And in all of these cases, it's both desktop and mobile. But those who don't support this proposal or haven't yet stated their intentions are Apple with Safari, and by extension of that, Chrome on iOS, because it's based on Safari. Mozilla Firefox has actually deemed this proposal as harmful. Samsung browser hasn't yet said what their intentions are, and the Brave browser will not support it. Another aspect to this is that the Android System Web View, which underpins almost every Android native app, there are currently no plans from Google to support the user agent client hints standard. So that's another consideration. And of course, any evergreen browser every non-evergreen browser that's out there in the wild will never support the standard naturally. So what's the timeline of all of this? When do you need to be getting ready? So the timeline for all of this is effectively set by Chrome releases. Chrome is now on a monthly update cadence. So starting from next month, things begin to really get in motion. Chrome 95, which is due to be released, I think it's on October 19th or thereabouts, kicks off a so-called origin trial. And what this means is that sites that choose to opt into seeing what this, how this will behave, can register with Google and get to see the new behavior. So there's an opt-in that begins with Chrome 95 in about 2 weeks' time. In April next year, April 2022, with Chrome 101, the situation in effect flips. It inverts to being a so-called opt-out trial or deprecation trial. And you can choose to opt out of this proposal at that point, but if you don't, you'll begin to start seeing changes. And the first change that you will see is that the Chrome minor version numbers will be zeroed out. That's the first change. 6 months later, with Chrome 107, we will see a fully reduced user agent string on Chrome desktop, and 3 months after that, the equivalent on Android. Then finally, in April 2023, the reverse origin trial ends, meaning that you can no longer even opt out to seeing the old behavior. You will have no choice but to deal with it at that point. So that's the timeline. It's set by Chrome. It's pretty solid at the start. The October date next month is looking pretty solid, but probably will get more less certain as time goes on, as the feedback comes in. So at this point, I would like to suggest that people head over to the Web Incubator Community Group. The URL is there on the screen, and have a look at the proposal, read the issues, but also look at the closed issues, because in our opinion, some of them were closed a little bit hastily and unilaterally. So have a look to the issues and see if they will affect you, because broad feedback is the best way to make sure this proposal works for everybody. So with that, I'm going to hand over to my colleague, John, to talk about the wider implications of all of this.
Thank you, Ronan. So I'm going to talk a little bit about the landscape. As soon as the mouse control works, excuse me one second. So first of all, there's a really big impact which is going to happen on the first request. So Google are in effect dividing traffic or users into two states, two classes, just desktop and mobile. So today on the first request, businesses can know precisely at a granular level what exactly they're dealing with, what their web user is using to consume or access their content. Google has determined that this will henceforth be two versions, just desktop or mobile. Now, what we know of mobile only is that it's simply not desktop. But this really does huge injustice to the diversity and richness of devices out there. The reality of the web is that it supports an incredible diversity of browsers in different device types. It's a spectrum and it's rapidly extending. And in a way, it's the original vision of the web that enables this to be possible. This is all going to be shoehorned back into the single classification of mobile on the first request. So this creates quite a headache for people whose business is about serving content. The problem really, with content, one size does not fit all. You really need to know, are you serving your page to a smartphone? Or are you serving it to a TV? Are you serving it to something with a 6-inch screen or a 6-foot screen? Does it have a mouse? Does it have a touch screen? All of these things matter when it comes to content consumption. And to perhaps illustrate how extensive the usage of the user agent string is today, there are over 2,700 user agent parsers on GitHub. It's an incredibly rich ecosystem that depends on the user agent string today. So, but in summary, all of that on the first request is going to disappear under just the categories of desktop or mobile. What is the likely impact of this? So the content and service providers really use their device knowledge to tailor the experience for their visitor. And why this matters is precisely because devices are so varied in their capability. But what you need to be able to allow for is, you need to be able to allow for not just high capability devices, but you need to allow for low capability devices, totally different classes of devices, but you also have to allow for poor connectivity, limited data plans, etc. And why this is important is because this has geographical implications. Firstly, in emerging markets, data is more expensive. Devices are less capable on average. And this also affects socioeconomic strata. So if you actually want to reach all users, both geographically and socioeconomically, you have to accommodate the device capabilities that you're trying to reach. And ultimately, the ability to adapt to the device protects your brand and extends your reach. So where does this change lead to? The key word is accessibility. For content to be accessible, you have to be able to consume it on your device. And this is now jeopardized on the first request. And the core problem here is removal of transparency from the ecosystem. By removing the transparency, accessibility is jeopardized. That impacts the disadvantage, and I would suggest that it is contrary to the vision of the web. So the real question here is the power of accessibility being traded for a very nominal or even questionable privacy improvement? This question is really pretty fundamental. So let's talk a little more about transparency. So transparency obviously drives confidence. It enables confidence, which enables trust, which is really the core of businesses. But there's one business in particular that is massively dependent on confidence and trust, and that business is advertising. Now, lots of people dislike advertising. It's probably a normal behavior, but the reality is that advertising is the enabler for content production and delivery on the web. So the question perhaps is, will the user agent client hints initiative affect all advertising players equally? What is actually going to happen in the landscape? So to answer this question, let's drill into the advertising ecosystem a little bit. So when an end user, a consumer, visits a web page, a publisher web page, their HTTP headers pass to the web server, and that includes the user agent string on the first request. Now the publisher passes that, in order to monetize their content, the publisher passes that user agent string to their exchange partner. The exchange partner creates a bid request, and this is under the the OpenRTB programmatic advertising protocol. The exchange builds a bid request, an invitation to bid, and they populate that with information, including information about the device. And the user agent string is used to do this. They populate the device type, whether it's tablet, phone, TV, desktop, or some other connected device. And they also put in quite a range of device information, such as screen capabilities and others. The exchange passes this invitation to bid to downstream DSPs, and there could be hundreds of downstream DSPs. The DSPs make a decision whether to bid to serve the ad to this user based on the information in the bid request, which includes the device object. So the UA string plays a really key role in enabling the transparency across the ecosystem to place a bid to serve an ad. So obviously, with the user agent string not being available on the first request, the client hints model string could be included as a field in the device object. So that all works fine. The IAB could extend the protocol to include it, but there's two problems. So first of all, it's the user agent string, the client hints model is not available on the first request, and that may eliminate a number of advertising contexts or use cases where really first request is everything. But the second problem is that it can be withheld by the client. Now, we don't know how often this will happen. That'll be very much controlled by Google policy and how the defaults are implemented. So in the event that the data is not available, all the advertiser or DSP will know is that it's either desktop or mobile. That means you've got a loss of targeting resolution. In effect, you can't target by device. So that results in less granular targeting and actually impacts the value, which I'll come to in a second. So the big question is, though, what proportion of traffic will be affected? And the reality is, this is not known today. This is not yet known. But to look at the impacts on the DSPs and exchanges, the advertising players, first of all, the DSP, they will have access to a reduced amount of inventory on which it is possible to provide granular device targeting. Now that ultimately reduces the effectiveness of that DSP, which in turn affects their advertising partners. So their advertising partners will be looking for an alternative. If their DSP has reduced effectiveness, their advertiser will look elsewhere. On the exchange side, the exchange will receive fewer bids, and those bids will have lower value because the targeting is less precise. It's precise targeting that drives up bid values. And what that means is less monetization or reduced monetization for their publisher partners. So their publisher partners will look elsewhere for somebody who can monetize their content better. So the question is, what happens then? The advantage in the ecosystem will be to the players with first-party knowledge or who own the platforms which the user is based on. And the challenge here from a regulatory perspective is, does the entity assuming control over the HTTP protocol here do they profit from the outcome? And that is a question which remains to be answered. So I'll talk a little bit about the DeviceAtlas solution and how we're managing this complexity for our customers. So firstly, what role does DeviceAtlas play in the ecosystem? So at present, DeviceAtlas enables its customers to have a deep knowledge of the visiting device on the first request. And this is really a key point because it enables speed of response. So DeviceAtlas currently tracks over 80,000 device models and it has comprehensive, structured, curated data on each. And importantly, all this data is non-PII. There is absolutely no user information at all. It's just information about the device and its capabilities. And this is used extensively for analytics, optimization, targeting use cases. So all of this intelligence will move to the second request under the client hints initiative. So in DeviceAtlas, there are multiple indexes which are worth talking to. So first of all, there's DeviceAtlas data is indexed based on the HTTP headers. And this now includes not just the HTTP headers as of today, but it also now includes a new index for the client hints model string. So that's a whole new index under the web umbrella. Secondly, the data is indexed for the native app ecosystem based on the make and model string as generated by the OS. Thirdly, the data is indexed on the TAC or IMEI, and this is in cooperation with the GSMA, and this is used in the mobile operator ecosystem to understand the device. And finally, there's a canonical identifier, the DeviceAtlas device ID, which is issued at the time of device release. The other identifiers effectively roll up under this one, and it enables an understanding to businesses of how devices behave across the different ecosystems. So it's a very powerful tool to understand user and device behavior across the different environments. So DeviceAtlas goals with the landscape change are the following. First of all, continuity. Our commitment to our customers is to look after the complexity, manage it, and just ensure the customer knows what they need to know, no matter what's happening on the web. So we absorb and manage the continued changes to landscape, whether it's new devices, new browsers, new OSs, new headers, whatever the changes are, we absorb that and pass through the intelligence. Secondly, a simple upgrade path. This is really paramount. Customers don't need to expend time managing updates and maintenance. So everything is always done through a simple data file update or a drop-in replacement at an API level. Thirdly, timing. Timing is always critical. We are tracking the Google proposals very closely to ensure we're supporting their phases, their milestones. And finally, extensibility. The DeviceAtlas commitment is to ensure we're extensible to support new and emerging use cases and capabilities as they emerge in the landscape. So the current status is we have a beta release available to customers to enable identification of devices using the client hints model string in conjunction with the other headers. So in effect, the business doesn't have to worry about where the signals are that they need. The DeviceAtlas APIs simply look after all of that. Now, our recommendation to customers is to schedule a test during Q4, and this is to ensure readiness for the Google changes in early 2022. And the reason for this is that although they are planning a reverse origin trial, which will allow customers to opt out of the changes for a period, this will not help businesses who support downstream business customers. Because if a business is in, let's say, a digital marketing platform or an advertising platform, they're providing services to downstream businesses. They can't expect all those downstream businesses to opt into the Google reverse origin trial. It's not really practical. So in effect, the clock really starts. The reverse origin trial won't really benefit businesses that are involved in any device intelligence, that are leveraging device intelligence today as part of their products and services. So this is a really important point. The reverse origin trial won't actually help in a B2B scenario. So what are the caveats arising as part of the solution? So Ronan's already mentioned these, but I'll just run through them very quickly. Firstly, the second request is required. This could actually, it'll certainly impact performance for all use cases, but it could actually eliminate some use cases entirely. A second request is simply too late or not practical, particularly for high performance switching environments. Secondly, the client may withhold the information. That means all you get is desktop or mobile. We don't know what the extent of this will be, because it will depend on default settings and implementation in browsers. And finally, the resolving power is reduced. As Ronan mentioned, you get model collisions. So multiple manufacturers can have a short model token. The effect of this sounds serious, but it's not as serious as it may appear, since mainstream manufacturers tend to have longer model strings. So the vast majority of traffic this won't affect. So it's likely to be a very small overall effect. But in any case, we are working on using additional signals to resolve the model in the event of a collision. And for the purposes of the beta, we don't return a result in the event there is a collision, because our policy is about transparency. And if we don't know the answer, we don't return it. So on the plus side, I think it's important to remember that the client hints project has actually a very powerful concept at its core of providing additional context signals through to the web server. And the information on connectivity is really important. And this is something we'll be embracing and extending and making sure we're passing through in a usable form for the web server. Round trip time and effective connection type, hugely valuable information, because if you're serving content to a visitor and you know they're using a high-end device, that isn't quite enough. It's useful to know more about their context, because if they're in a really busy trade show or an airport lounge, they're going to have really constrained connectivity. Now, I'm sure some of you are regular trade show attendees. You're possibly even missing them at this point. But everybody would know that constrained connectivity means really slow experience in a trade show or an airport lounge. In that scenario, it makes sense to serve a lighter page, because shoehorning a heavy page over a narrow pipe, even to a high-end device, is a poor experience. You're highly likely to have a bounced user or a lost visitor entirely. Also, user preferences, very valuable to know. If a user has a limited data plan, they can set a flag at the OS or browser level to indicate this. And sensitivity to a user's data plan is really important in serving content. There's no point pushing a 1 megabyte image down a narrow pipe to a device on a limited data plan when a 100 kilobyte image will provide just as good an experience on a small screen. So what's the evolution plan? So today we are supporting identification using the model token, the client hints model token, and that's currently in beta. In the next phase, we'll be leveraging additional client hints to return context information. So this, in effect, will make it very easy to use the additional context information within the overall response to the visitor. And in the third phase, we'll be taking a step further. The problem Ronan mentioned about huge numbers of devices out there not supporting client hints today. DeviceAtlas is available in a web server module form for Nginx, Apache, and IIS. And what we plan to do is, for devices that don't support client hints, we'll be able to generate client hints for the devices that don't support it. So this will allow downstream applications to use the client hints model token for whatever purposes they need. So in effect, DeviceAtlas can help manage the transition to client hints by injecting client hints headers for all devices that don't support it today. So in effect, it smooths out the landscape and it smooths out the migration to the new environment. So to sum up, so businesses do face a decision. How will they manage the user agent string or client hints? How to look after the combination? The reality is that DeviceAtlas will simply handle that transparently for the customer. And our motivation is that the DeviceAtlas vision is to deliver on the promise of the web, accessible to all, irrespective of device. So we do invite you to try it out and discover why DeviceAtlas is the choice of market leaders.